Okay. So yes, most of them today is dealing with how do you do coordinates instead of doing coordinates as 2 comma 3 over 2 up 3. How do you do coordinates if you want to say, oh, I went in a certain angle direction for a certain distance? How do you connect to those two? But it also, this is going to tie to complex numbers, so we have to see how that happens. I need to do a real quick 5-minute, do you remember anything about complex numbers before we roll with this? You're already shaking your head, no. Seriously? Can anybody name me an example of a complex number?
Like a regular number plus or minus something.
Yeah. Technically, they're numbers in the form a plus bi, but in other words, where this is a real number and that's an imaginary. Together, though, you put them together, it's considered to be one number. 7 plus 4i is one number. That is one complex number. It's not two separate pieces. So I just need to check if you remember the basics, the algebra of them. If I gave you two complex numbers and I said add these together, can you add them together?
You can add the...
What do you add?
The fourth part with the other fourth part and the second part.
Yeah, that's supposed to be two. It kind of cut off. So, yeah, you add the real numbers, you add the imaginary.
Yeah.
It's add like terms. That's all you're doing. What are you going to get? Yeah, FOILing is coming. But this is addition. There's a plus sign in the middle. So, yeah, we're literally just going to add those two together and you add them. You add like terms. Then, but however, if I did give you something like 2 minus 5i times 3 plus 4i, how do you suppose you multiply them? That's FOILing. Now, does anybody remember the extra little thing you have to remember to do at the end of the FOIling? Because, okay, no big deal, you can FOIL this. What? My question is, what are the last going to give you? Yes, I'm going to get minus 20i squared, okay? We know something about the powers of I.
I forgot the powers of I.
How many powers of I do you have to know in order to do all of them? Thank you, there are 4.
And the third one, I think, is dormant or something.
So, did anybody remember the saying I taught you for these? I1.
Negative.
Negatives where?
In the middle.
In the middle. 2 negatives in the middle. The middle terms are, middle ones are negative. Okay. So that means then, what can I do with I squared?
Negative.
Yeah, and that's the most. I squared is by far the most common one you ever see. And so anytime you see an I squared, you go, oh, that's really -1. So I can cancel that out and make that become plus 20. So it just, you take the I squared out, it's going to make it become a positive 20 then when you multiply it by -1. And now add up your like terms. What do you got? 6 plus 20 is 26. 8i minus 15i is minus 7i. So we have 26 minus 7i. So multiplying them, not that big a deal either. Yes, you have to remember your powers of I. That's kind of important. What's the hardest thing you're going to do with it? Okay. Well, algebraically, because I'm actually going to show you some shortcuts. What would be hard to do with complex numbers?
Divide.
Well, how much fun would it be to take 7 plus 2i to the 8th power?
That would be a pain.
That would be a pain. Why?
Because you have to take that FOIL.
Well, 8 times by hand would be horrible. Okay, well, I'm going to, by Thursday, I'm going to show you that if you change it out of this form, this is called rectangular form, because we have essentially an x and a y coordinate here. I'll get to it in a second. And to do it by algebra, this is very difficult. It's a big pain. We turn it into what's called a trigonometric form. I can take it to the 8th power in a snap. It's PUD. It's super simple. So that's why part of the reason we were going to change it over. Something like that by algebra is a pain. The other thing that's a royal pain, what if I said solve this? X cubed equals 6 minus 4i. Okay, how do you solve for x when it's x cubed?
You have to cube root it.
You have to cube root it. Okay, how are you going to figure out How are you going to figure out the cube root of 6 minus 4i?
You can't.
You can't.
Basically like a boot in a boot.
What are the cube roots of 6 minus 4i? Who knows? But, once again, when we change it into this trig form, we will be able to figure out what you actually get when you take the cube roots of it. So, that's actually the reason we do this section. That's where we're heading by the end of Thursday. You will know how to do this in a much easier fashion. Those two problems, which by algebra are either we don't know how to do it or are very difficult, you change them into a trigonometric form and suddenly they're way easy. But we have to learn some intermediate steps before we can solve those. But that's where we're eventually going, is how do I solve something like that? I probably should check while we're doing powers of I. If I said what's I to the 17th power, how did you quick figure that out?
4 goes into 17 4 times. You left 1.
Yeah.
It's I.
We do it repeats every 4, so you just had to divide it by 4.
Find the remainder.
And find the remainder. Okay, this is an easy one. We could divide this one by 4 by hand. It goes in 4 times, and the remainder is 1, so that means it's the same thing as I to the first power. Okay, but if I gave you, say, I to the 298th power, if you divide it by 4 in your calculator, do I know if I've just written down?
It's like 0.25, 0.5.
If you do 298 divided by 4 in your calculator, you're going to get something, but it's going to have a 0.5 as a decimal.
Third power.
I got one saying it's the second power, one saying it's the third power. Why? Half. Half would be 2 out of 4, wouldn't it? So that means the remainder was 2. It was the same thing as I squared. So I to the 298 is the same thing as I squared, and so that would just be -1. Okay. So.
Isn't like the I to the 3rd decimal?
Yeah, well, what would 3/4 be?
0.75.
0.75. So if your remainder is 0.75, it's I cubed. If it's 2/4, that's a half. If it's 1/4, that would be 0.25. So that tells you you're on I to the first. What happens if it's I to the 4th? It divides evenly. You have no remainder. So technically, I guess if it's 0.0, if it divides evenly, then you know you're on I to the 4th power. So yeah, that's the quickest way to do it. Is that a major big event? Okay, you're a little bit back to complex numbers of what you knew about complex numbers, but we actually want to go to the trigonometric side of this. But before I can go there, I have to teach you what a polar coordinate is, and I have got to change. Actually, I'm going to pause this a second. Okay, reading this, we're going to graph some of these by hand. Yes. Okay. First of all, you'll notice you have 0, 30, 60, 90 around the outside. So what are these other lines that are extending out? Yeah, it's every 10 degrees is what you got here. You got 10, 20, 30, 40, 50, 60, all the way around. Okay. So it's not like it's super difficult to read. Okay. How do you plot coordinates? When we normally plot coordinates, if I said plot 2, -5, you all go, how on it? Yeah, we know that, that's over 2, down 5, and we plot our point. Those are called rectangular coordinates. Where you have an X and a Y, that's rectangular. Okay, instead, I want to do what are called polar coordinates. Okay, it is not polar because it's cold. It's not, you're not going to get cold touching this graph paper. Why polar? Poles, yeah. Like North Pole, South Pole. We have a pole. The pole is the center point, and everything goes around it in a circle. So the origin is like the pole. Yeah, you can take notes on it because I think you're only graphing 2 on your assignment. Okay. Yeah, you can take notes on these because you only need 2 or 3 for your assignment, and you're only going to draw 1 on here, so not that big a deal. Okay. So how do they give you polar coordinates? Instead of giving you an X and a Y, they give you a radius and an angle. So if I was to give you 3, 60 degrees, how do you suppose you figure out where you would plot 3, 60 degrees? Yeah. So you have to go to the 60-degree line, and if the radius is 3, that's what each of the rings are. Each of the rings is 1 unit. So you would go to the 60-degree line, and you would count out 1, 2, 3, and you have plotted the point 360 degrees. Okay, you really don't need to put this on your graph paper. I'm going to do a full graph here in a minute. So that's all you're doing on that side of it. I should have duplicated this page. Everything on here is pretty much curves. This is not going to have straight lines, yeah. Okay, now, what do you do if I was to give you, say, what would be an easy one we can track? Suppose I gave you -2, 120 degrees. How do you do a negative on this? Yeah, you go to the 120 line, but to go -2, you would have to go opposite of 120. Well, what's going to be opposite of 120? The 300 line down here, yeah. So you would actually go 2 units backwards in this case on that same line. So yes, so -2, 120 is the same thing as +2, 300. Notice the angles are different by 180 degrees. Yeah. So you can actually plot it either way. Okay, so who would want to do stuff by this kind of coordinate system?
Some insane person.
Pilots, submarines,
The Navy and the Army.
the Navy, shipping on this, anything where we don't go places by going over and up and down. We go places direct. If you're going to fly from Seneca to Chicago, you're going to fly at a certain angle for a certain distance. You're not going to go over and up to get there. It's inefficient. So this kind of coordinate system is very much used in the real world. Simone, if you're going to aviate, I'll bet you're going to get good at these kind of coordinate systems. Okay. Okay. Simone, you have taken flying lessons? No, but you've taken flying lessons, yeah. He wishes to be a pilot. So. Yeah, thank you, I do. I need to raise that point out here, too. All right. What I want you to do is actually to create a polar graph. And yes, while your calculator can produce this graph for you, I need you to learn how. You've got to plot a couple of these by hand to get good at polar coordinates. Okay, so if I want to plot one of these, I technically need coordinates to plot. But I'm not going to have an X and a Y in my T-table this time. Yeah, which one's on which side? Which one? Are you going to want to pick the angle and find the radius, or are you going to want to pick the radius and find the angle? Yeah, you want to pick the angle, fill in the angle, and that'll tell you the radius. Okay, and in our case, since we have our graph papers are nice every 10 degrees, yeah, we'd like it to just let us plot that fairly easily. Okay, I'm not going to write these all out once we discover that we can get this to work here.
Aren't these the graphs that get curvy?
Okay, now, yes, these go all kinds of curvy. Yes, these are pretty graphs. They really are. Now, back in the day, before I had super high-power calculators, we actually had to sit there with our calculator and punch in 2 plus 3 cosine of 0 degrees, 2 plus 3 cosine of 10 degrees, 2 plus 3 cosine of 20 degrees, and we had to get all those values. And that would still work, but shouldn't there be a better way?
Something tells me there is.
Yeah, well, this is what we have to discover, because Mrs. Meyer forgot she needs to realize how to do this on the Inspire, so we got to find where this is hidden on the Inspire. But, yeah, it's
In the menu, there's a polar.
yeah, there's a polar, but I want it to get me a list of coordinates. I want it to actually show me a table of value for all those coordinates. So, yeah, we're going to need to go to the table of values, but before we can do Control-T, it's got to know what equation is it plotting. So where have we normally entered equations? In a graph, yeah. So I actually need to be on a graph page. If you're on your it's up to you. If you're in the scratch pad, you can do a scratch pad graph, or you can start a new document. If you want to save this, you can start a new document and create it. I'm going to do a new document just to be. No, I don't want to save that. Okay, but problem is, our graphs is set up to do an f of x graph. I don't want to do I'm not doing function graphing. I'm doing polar graphing.
Okay, there's one in the menu.
And so we have to tell it that, hey, dude,
Graph entry.
I don't want to enter a function. I want to, yes, change the graph entry to polar. Okay, and notice now it's instead of F1, it wants R1. So what I just told you, I wanted to graph 2 plus 3 cosine. So we are going to put in 2 plus 3 cosine. There you go, dude. But 3 cosine of what? It wants theta. See, it's got R of theta. It needs theta there. Where on earth am I going to get theta?
In the symbol thing, like the pi, the arrow. On the keyboard.
You get, okay, there's that pi, not there.
Isn't the pi
You're going to have to make me escape, aren't you, dude?
Go to pi.
I'm trying.
You can't hit pi.
I got to get out of there. Pi. Okay. Yeah, it's under your pi. You can put in a theta. Oops, thank you. I have a E. Didn't realize I hit that. Okay.
I always would have made anyway e pi.
Happened with me too when I did that.
Something very interesting.
What happens if Maya do tell?
It depends on whether, because that EE, is that scientific notation EE? I don't know, it might have just told us error. I don't know how it would have taken that.
Yeah, error syntax.
Okay.
What's syntax?
Syntax error simply means a typo error. It's error in what you typed. It doesn't mean hit your pi key.
Yeah, it's like a programming grammar error. Like, you like.
Okay, now, this thing will attempt to graph this, but I don't want to graph this, and if you cheat, I'm going to be mad at you. Okay, I actually want to graph this by hand. I want it to produce a table of values because I want you to create it on your graph paper. So how do I get this to create a table of values for me? Good old Control T. Yes. Dude, you didn't go.
Why aren't you working, man?
Oh, I have an enter. That's why. Duh. Enter. You see it graphed it already. See, you're not supposed to see that.
It looks weird.
Yep. Okay. Yeah, I did Control T. I want the actual table of values. Okay, but this is calculating. Notice it's changed to theta, so it's saying angle theta is 0, then at 1 degree, 2 degrees. You want to plot this by single degrees? By the way, I have some graph paper that's got every single degree on it. If you want to do that.
Why are you going down?
So what should I do so I can get this to do every 10 degrees? Menu table settings. Table settings, and I would want my step to be 10 degrees, not. I went to menu table, changed the table settings.
Okay.
So step by 10 degree increments. We don't need to plot it that accurate. But if anybody really wants to do every single degree, I'll be happy to give you a piece of graph paper that will do that.
That would be a very, very...
It's one big circle on a side, and the lines are so close together. Yeah, it's overwhelming to look at.
How would someone create something like that?
Well, if you want to plot that accurately, you can. Okay. Now, here my problem is you all have a calculator in hand, and you can sit there from your graph paper. You can sit there and plot this. I've got the problem of I need to plot back and forth. I should have got a hand calculator so I can. You all have to read me coordinates here. But you're going to actually go back to your graph paper, and you're going to go, okay, at 0, it was at 5.
Yep.
So I would have to go from 0, I'd have to go 1, 2, 3, 4, 5 rings. Okay, at 10 degrees, it was 4.95. So I'm going to be just a little bit less. Then it was 4.8.
Yep, for 20.
And then what?
And
This is going to
4.59.
go to spiral, isn't it?
Kind of, yeah. A lot of these spirals.
What is it called?
Okay, and then am I going to be at 3? Or 4, I should say?
40 is 4.2.
4.2.
50 is 3.9.
3. Okay. 3.9.
3.5.
70 is.
3.
You just need to read them off your graphic.
0.02.
Okay, so I'm right, almost 3, just real close to 3.
Then 0.5.
Notice this thing's really dropping in.
Yep.
90, it should be 2.
Yep. 100 is, whoops, what happened?
100 is 1.4.
1.4-ish, okay. Now, it gets a little harder in here as you get to the center because they didn't carry in those other lines. So you're going to have to guess a little bit as you get closer, as it goes more toward the middle. But is there a clear pattern here? I mean, as you connect the dots, you can see, okay, we got a definite curve coming in. I am ready for 110, which is probably going to be around 1-ish.
Yep.
Or less.
It's like 0.9.
0.9, okay. And then at 120.
It's 0.5.
And they don't always go to the middle, but they go to the middle a lot. 0.07. So okay, well I'm like tiny close in here.
And now we're on negative.
And now this is where I wish you hadn't cheated and seen what it was already going to do, because this is where you start getting negative. And it's like, well, why would I get negative? So if I'm at 150 and I get a negative number, I get a negative what?
150 is negative 0.59.
Okay, negative 0.59. So it's got to come through on the other side.
Yeah.
Negative 160 is going to be some tiny.
Negative 0.8.
And then I'm going to get negative 0.9 something probably.
Yep.
And then I'm going to get negative 1
Yep.
when I'm at 180. So what does this thing do?
It's like close to 100.
You have to continuously connect the dots. So therefore, if it's coming this way, then it came through and it's continuing to loop around. Now, most of them have symmetry to them somewhere. In our case, we got lucky. This one is perfectly symmetric at 180. If you start looking at the numbers after 180 degrees, you'll see that you have the exact same values we just plotted going in reverse order. So it's going to create this exact same graph going right back out to where. So this is going to intersect, yes, right here at the origin. It's going to do 0.9, 0.8, 0.7. Then I'm going to be back, or that was 0.5, I guess. And then it's going to come back out here. It's going to continue to just loop around. And then come back out. When do I go to positive numbers at?
You go with positive numbers at 240.
120.5, that's it.
Okay, I need to be that.
92.
No. I'm way past. I'm past 180.
Those are the numbers for the same number.
Yeah.
The positive numbers at 230.
Thank you. That's what I wanted to know. And 240, 230. So I'm back out here. Is that the 0.07 something?
Yeah.
Okay. And then I'm at 0.5-ish.
Yep.
And then I'm close. I'm at 0.97. So there you're going to see the exact numbers coming right back out. 0.97, then about 1.5,
Yep.
2 when I'm straight down at 270. And then I had 2.5,
Yep.
slightly over 3, 3.5. Actually, oh, shoot, I forgot to have you check radius and degrees. Obviously, what are we in?
Radian.
Degrees.
No, degrees.
Oh, degrees, yeah.
Yeah. You got a calculator that makes this so easy. Won't kill you. Heavens. You're sitting there looking at it on your screen, and you'll get very good at these. Okay, then I was at 4.1, 4.5. I'm just matching the points I already had here. Oops, I'm too off. Nope. Am I out of ring too far?
We'll just start over
I'm just going to go, yeah, I'm going to come back. Because I don't have my points that I can see. If I had them, okay. I'm just slightly off. Okay. So this baby came right back out again. You have to go completely around the full 360 to get the whole graph. That's not a very smooth curve out there. I'm off a little bit right here. That must be there. That makes it a little rounder.
So we're going to have rehit and plot one of these?
You're going to plot one of these, yeah. You're going to plot one of these come test time. Okay. Were you going to error the whole time?
Yes.
Okay. So that's a complete one. They make all kinds of different graphs. Oh golly gee, I didn't realize you all should have told me I need to stop this like 50 minutes ago. We are way over time here. We're going to go stop and look at the book a second. I'm stopping you now.